We're going to do a couple examples of solving proportions. The way that we solve proportions, as you remember, is we cross multiply. So whenever we solve proportions, we're going to cross multiply, so we can do 2 times x is equal to 9 times 7, which is 63. Solving for x, we would divide both sides by 2. And we get x equals 63 halves, which I'm okay with. It's reduced. We can write it as a mixed number, and that would be 31 and a half, or 31.5. So that's how you solve that one. Nice and simple. The next one has a binomial here in the numerator. We're still going to cross multiply. We just have to be careful when we multiply here. So I'm going to go ahead and multiply the 3 times the x plus 5. Realize it is 3 times the whole numerator there, x plus 5, which we have to put those parentheses there because we need to distribute. And then we have the 4 times the 2, which is 8. Distributing, we get 3x plus 15 equals 8, and then we can subtract 15 from both sides, and we get 3x is equal to negative 7, and dividing both sides by 3, we finish with x is negative 7/3. And again, if you wanted to change that into a mixed number, you would get negative 2 1/3. So either one of those answers is fine. Next one is an application that we learned about similar figures. We can use proportions to solve similar figures. So what we want to do here is we want to find the relationship between these two similar quadrilaterals. And so we find corresponding parts that we know both of them. We could use the 14 over the 11.2, or we can use the 35 over the 28. I would use the 35 or 28. Then I just can avoid using decimals. So we know 35 over 28, that's going to be the ratio of the sides. We could reduce that if we wanted to, and we will in a minute. And we know 35 over 28 is going to be equal to this side, 15, over a question mark. I'll put an x there. And so when we have similar figures, it says similar triangles. These are not similar triangles, similar quadrilaterals. We find the ratio of corresponding sides. So I took the longest side of this top one over the longest side of the bottom one and set it equal to this slanted side on the top one compared to the slanted side on the bottom. What I mentioned before is we can reduce this. 7 goes into this 5 times, and 7 goes into this 4 times. And now what we could do is we could cross multiply. Also, as we learned before, another way to solve this is we realize that 5 times 3 gives me 15. So we would need to multiply 4 by 3 to get this number. So we would know that x really is just equal to 12. But again, if you didn't remember that, it would be 5x. So cross multiplying, 5x is equal to 60. And we could divide both sides by 5. And you would still get that x equals 12. So if in doubt, you can always cross multiply, but also remember this thing with the yellow arrows I put in there. Another one dealing with similar figures, we learned about this before. If the ratio of the sides of two similar hexagons is 5:3, what's the ratio of their areas? Well, we're going to do a quick review over this whole thing. We know the ratio of the sides is 5:3, and what we learned, which isn't part of the question, but we learned the ratio of the perimeters is the same as the ratio of the sides. So the ratio of the perimeters would also be 5:3. We learned the ratio of the areas, which is the part that we're looking for, is actually you take the ratio of the sides, which is 5:3, and square it, which means we multiply it by itself and we get 25/9. And then, so that's the answer to this question. The last thing we want to look at or be reminded of is the ratio of the volumes, and what you do is you take the ratio of the sides and you cube it to find the ratio of the volumes. And so 5 cubed is 5 times 5 times 5, that's 125 over 3 times 3 times 3, which is 27. So our answer is 25/9. but there's a reminder of the other two things that go along with that. We'll go ahead and stop there.